Hello guys, once again I welcome here all of you in this marathon session where we discuss numeric portion of environmental engineering, previous year questions of environmental engineering. Guys, we have completed numeric portion of quality of water, and today we're going to discuss some previous year questions of quality of water of gate examinations. Okay, so basically we discussed it from 2008 to 2020 of gate examination questions, which is previous year questions of gate examination. So let's start it. So here the first question, guys, which is denoted as 2.3. It's question. This question is a wastewater sample contains 10 to power minus 5.6 millimole per liter of OH minus ion at 25 degrees Celsius. The pH of this sample is, what is the pH of this sample? We need to find what is the pH of this sample. Okay, so guys, we have concentration of OH minus is 10 to power minus 5.6. Okay, and but remember guys, this is in millimole per liter, so we need to convert it into mole per liter, so it is about 10 to power minus 8.6. So for if you need the pH, we know that pH plus POH, oh I'm sorry, give me a second. We know that pH plus POH is equal to 14. So if you need pH, you need to 14 minus 8.6, which is 5.4. So option D is correct answer. This is question of 2008, which is 2 marks of gate examination. Let's move towards our next question. This is the column question. This question is also from gate 2008 of 2 marks question. Let's discuss it. Here we have a match list of list 1 and list 2. We need to match this. In list 1 we have the estimation method. In list 2 we have the corresponding indicator. Okay, and select the correct answer using the code given below the list. Okay, so let's discuss the first list. We have in first list we have A azide modified Winkler method for dissolved oxygen. We have B dichromate method for chemical oxygen demand. We have C EDTA titrimetric method for hardness, and we have D Mohr or argentometric method for chlorides. And in list 2, which is indicators, in list 2 we have indicator from black tea, ferroin, and potassium chromate and starch. If you see this, guys, you got the point that in EDTA we have indicator erichrome black tea. Okay, so it is true that the C is correct for matched with 1. So these two, wait me a second. So these two options are eliminated because here C is not 1 So we need to choose one correct option from these two, A and B. So C is from erichrome black tea, and we need to find, and here you see that Mohr argentometric method for chlorides, and for chlorides we have potassium chromate. So for D it is 3. D 1, for D it is 3, and C it's 4. So option B is our correct answer. So in this match, the best thing in the match the columns question type of question, that you need to rectify one, or you need to get one or two correct answer, and you get the whole match the column get corrected. Like here you only know about that EDTA is a indicator of EDTA erichrome black tea, and if you know one more thing, that here in chloride you get a potassium chromate, you easily get the answer like this answer. So here azide modified Winkler method for dissolved oxygen, we have a starch indicator. In dichromate method for chemical oxygen demand, we have ferroin indicator. Okay, so this is the correct answer, option B. Let's move on to our next question, that is this is that common data question, that following chemical species were reported for water sample as well. That we have this species given here, that chloride for given that concentration in milli equivalent per liter. Okay, for chloride we have 15.5, sorry, for chloride we have 15, for sulfate we have 15 milli equivalent per liter, for carbonate we have 5 milli equivalent per liter, for bicarbonate 30 milli equivalent per liter, for calcium we have 12 milli equivalent per liter, for magnesium we have 18, and we have an pH that 8.5. Okay, so we need to find total hardness in milligram per liter as CaCO3. So if you guys know that hardness is caused by these two, only for these two, calcium and magnesium. So let's say, and we need to find total hardness in milligram per liter as CaCO3. So by using the formula that we have a 12 milligram equivalent plus, for magnesium we have 18 milligram milli equivalent, and it's multiplied by 50, we'll get 30 into 50, and it's 1500. So option A is correct. And here our next question in this, which is related to this data, that alkalinity present in water as milligram per liter. So alkalinity species which cause alkalinity is this two, CO3 2 minus and SCO3 minus, and for this is total hardness, and here alkalinity. That for carbonate we have a 5 milli equivalent per liter, and for bicarbonate we have 30 milli equivalent per liter. Multiply it with 50, which is milli equivalent for CaCO3, you get 35 into 50 by multiplying it with 1750. So 1750 is your correct answer, which is option C given here. So this is the gate question of 2009 with for 2 marks. Okay, so this is it in this question. We have given this, there's a given this data, and we need to find total hardness and alkalinity. Guys, here if it asks that what is the carbonate hardness, so carbonate hardness is basically, carbonate hardness is the minimum of total hardness and alkalinity. So here if they ask carbonate hardness, then carbonate hardness is equal to 1500, because it is minimum in both of these. Okay, so here let's move towards our next question, which is again a common data common data type question. Give me a second. Here we have ion concentration obtained for a groundwater sample having pH 8.1. Having pH 8.1 are given below. We have ion concentration for Ca2 plus it's 100, for Mg2 plus it's 6, for Na plus it's 15, HCO3 minus 250, and SO42 minus 45, and Cl minus 39. And we have given there's a given that respective atomic weight. Okay, for CO, Mg, Na, H, HCO, and SO and Cl. Okay, and we need to find here again total hardness and carbonate hardness. So let's see the first thing, that in 2.47 questions, that we need to find total hardness as milligram as CaCO3 present in the above water sample. Okay, so again hardness is caused due to Ca2 plus and Mg2 plus. So we have an ion concentration of Ca2 plus 100, and we need to its atomic weight is 40, and divided by 2 we'd get 20 into 50. Oh, into 50 plus, for Mg2 plus we have 6 milligram per liter ion concentration, and its atomic weight is 24, which is divided by its valency, that is 2. So we get 24 divided by 2, which is 12 into 50. Okay, So if you solve this, you'll get the value. Okay, so it's 5, and here we get 2. So 5 plus 1 by 2 into 50. Okay, it is 2. So 5 to 10, 11 by 2 into 50, which is 11 into 25, and you'll get about 275 your answer. So our C option is the correct answer. And for carbonate hardness, we have to find alkalinity first. So there is only one thing due to alkalinity, that HCO3 minus. Okay. So due to HCO3 minus, we have a 250 of its ion concentration divided by its atomic weight, which is H plus C plus O3 plus 1. So that here, that due to H1, due to C it's 12, and due to O it is 16 3s of 48, and due to its valence plus 1. Okay, into 50. So it's about 250 upon 50, 60, 61. No, it's not. Wait a second. We basically not add valency here. Yeah, we divided by valency 1. So 48 plus 12, it's 60, and plus 161 into 50. Okay. So if you solve this, let's solve this first. So and if you solve this, we'll get an answer of around 204.9. Let's say it's our A option is correct. Okay, as you if 250 is divided by 61, we'll get 4.09, multiplied by 50, we'll get 204.9. Okay, so 205 is correct answer. This is question of 2010 of GATE examination. Both are is equal 2 marks question. Okay, let's move on to the next question, that which is basically from MPN most probable number, that anaerobically treated effluent has MPN of total coliform 10 to power 6 per 100 ml, and after chlorination, the MPN values decline to 10 to power minus 2 per 100 ml. The percentage removal R and log removal log R of total coliform MPN is. So for anaerobically treated, MPN is total 10 to power 6. If you guys remember, we have a percentage removal formula, that if you use total coliform 10 to power 6 minus, and after chlorination it is 10 to power 4 divided by 10 to power 6 multiplied by 100. Let's solve this. Multiplied by 100 and cancel this to 100, and you'll get 99%. Okay, and let's find log of this. So log R, will get log R is equal to log 10 to power 6 minus log 10 to power 4, and we'll get 6 minus 4, which is equal to 2. Okay, wait a second, is everything okay here? 10 to power 6 minus 10 to power 4. Wait a second, give me a second. Let me check once again. Percentage of 10 to power 6, we'll take it 10 to power 4, 10 to power 2, 100 minus 1, which is 99. 100 minus 1, which is 99, and here at the bottom we have 10 to power 6 and 100 minus 199, 100 cancelled. Everything is correct here, and we need to find and r is a log 10 to power 6 minus log 10 to power r. Okay, so 10 to power 6 minus 4, which is equal to 2. So everything is okay here, but as if we go further by divided this, it's about 19.99% as we go further. So let's choose this option. D is correct answer. Okay, so yeah, it is this. We solve this question like this by using these two formulas for log with log 10 to power 6 minus log 10 to power r. So 6 minus 4 will get 2, and percentage r 10 to power 6 minus 10 to power 4 divided by 10 to power 6 of total. So yeah, this is it. This is question of 2011 of 1 mark question in GATE examination. Okay, let's move on to our next question, which is that here we have a chlorine gas of 8 milligram per liter as Cl2 was added to the drinking water sample was added to as a drinking water sample if the free chlorine residual pH of measured to be 2 milligram per liter and its pH is 7.5 respectively. That residual of pH free chlorine is 2 milligram per liter and pH is 7.5. So what is the concentration of residual OCl minus ion in the water? We need to find concentration of concentration of. Yes, sorry for the disturbance, guys. This is due to the some network issue. Let's back on our question that we need to find concentration of residual of OCl minus in water. Assume that chlorine gas added to the water is completely converted to HOCl and OCl minus. Okay, and its atomic weight of Cl obviously 35.5. We have given a equation that OCl minus plus H plus K HOCl. Okay, so we have HOCl. By reforming it, we'll get OCl minus and H plus is equal to K, and value of K given is 10 power 7.5, and we have a pH of 7.5. So HOCl upon OCl minus is equal to 10 to power 7.5 into pH of 10 to power pH of 10 to power minus 7.5. So it's both cancelled and we'll get value of 1. So HOCl is equal to OCl minus. Okay, we'll get this value, these two values, and after that we have a free chlorine residual. Oh, give me a second, guys. Yeah, free chlorine residual. Free chlorine residual. We have value of HOCl plus OCl minus. Okay, and free chlorine residual we have 2 milligram per liter. 2 into 10 to power minus 3, and here 2 into 35.5, and HOCl and OCl both equal, so write it as 2 OCl minus, and by solving this we'll get a value of let's solve this like 1 divided by 35.5. So it's about, you know, it's about 2.817 into 10 to power minus 5. So 2 into OCl minus divided it by 2, we get OCl minus. Okay, and if we divide it with 2, we'll get, so 2.817 divided by 2, we'll get 1.4085. We'll get value of 1.4085, 1.4008, man, 1.4085 into 10 to power minus 5 mole per liter. So yeah, option A is the correct answer. Okay, so yeah, this is it. This is a question of 2011 of 2 marks. Let's move on to the next question, which is in which we have a water sample of pH of 9.25, and here we need to find the concentration of hydroxyl ion in the water. Okay, we have a pH given that 9.25, and we need to find a concentration of OH minus. Oh, sorry, OH minus. Okay, so we have a pH of 9.25. So as pH plus pOH minus, we'll get P of OH minus is 14 minus 9.25. If you minus 14 minus 9.25, you will get, that's minus 14 minus 9.25, we will get 4.75 approx, 4.75 of the value. Okay, and we have a given value 4.75. so we have P of OH minus. So here log OH minus, shit man, give me a second, log OH minus, that is 4.775. so OH minus is given that OH minus is equal to 10 to power minus 7.5. Okay, 10 to power minus 4.7 10 to power minus 4.75. so 10 to power minus 4.75. if you find it, we'll get a value of 10 to power minus 4.75. so 4.75 to the power of 10. So 1 divided by 56234.13, and if you calculate further it, and we'll get a value of 1 divided by 56234.13, we'll get value of 1.77 into 10 to power around minus 5. But here we need to think one more thing, that we need this in moles per liter, so multiply it with moles per liter of 17. Okay, so if you multiply it with 17 in per liter, you'll multiply also it with 1000. so we'll get a value of about 0 point, we'll get value of 0 point around 3023, 0.3023. so where this option C is the correct answer. Okay, look, one fantastic thing in this question, that here in option you'll also have a option that 10 to power minus 4.75, but remember this here is its unit, that millimoles per liter, so this option is not correct. You need to change this in milligram per liter. Okay, so here you change its mole to milligram, and here by multiplying it with 1000, here you change it to milligram per liter. Okay, so this is option is, this is your correct answer. This is not a correct answer because it should be in gram per liter, which is, but here it is given in milligram per liter. Okay, and this is not an option. So you need to find your option in from these three one. Okay, so this is your correct answer. So this is from 2012 of 2 marks question. Let's move on to our next question, that is 2.52, that some of the non-toxic metals normally found in the natural water. Basically it's a theoretical questions, and here we need to find that some of the non-toxic metal which is normally found in natural water. So if you see these given options, you'll easily get that iron, manganese and magnesium are some of the non-toxic metal which are found in the natural water. Okay, let's move on to our next thing, that 2.53 question. Basically it's a question of 2014 1 mark question which is asked in set 1. Let's move on to our next question, that a groundwater sample was found to contain a 500 milligram per liter 500 milligram per liter of total dissolved solid. We need to find a total dissolved solid in per in percent. So 500 milligram per liter given. So for percentage divided by, then multiplied by 100. You need to find more thing. So it's about 0. Isn't it? It is 0.5%. Yeah, 0.5%. It's per percent. Okay. You need to change it from milligram to gram and liter to. You need to remove the liters and multiply with percent. So you'll get this about 0.5% of total dissolved solid. Okay. And let's move on to the next question, that the hardness of a groundwater sample was found to be 420 milligram per liter SCSO3, and a softener containing ion exchange resins was installed to the residue. The total hardness of it was 75 milligram, reduced to 75 milligram per liter as CSO3. Basically, in this question, there's a the hardness of groundwater sample is found to be as 42 milligram per liter as COC3. Then we add a softener containing ion exchange resins installed in it, and then our total hardness is reduced to 75 milligram per liter as COC3, CSCO3. Okay, so before supplying it to 4 households, each household get treated water at the rate of 540 liter per day. It's the flow rate basically, that each household get treated water at the rate of 540 liter per day. If the efficiency of water softener is at 100%, efficiency of water softener is 100%, then the bypass flow rate expressed in liter per day. Basically, in this question, we can solve it by two method. One method is that you draw the flow chart that there is a 450, isn't it 450? Yeah, it is. No, it's 420. Let's say that 420 milligram per liter of carbonate hardness 1, and we had softener, let's say it's carbonate hardness 2, which is 0, and because it's softener, and after mixing we'll get 75 milligram per liter. Okay, so we have formula that CH mix is equal to C carbonate hardness of 1 into flow rate plus carbonate hardness of second into their flow rate plus carbonate hardness of second into their flow rate upon total flow rate. This is the basic formula, and let's find first the total flow rate, that 540 liter per day. 10 to the power 3, sorry, and divided by 30. Let's 3600. Let's find it. Let's calculate it. At 540 by 36. It's 40. Give me a second, guys. We need to find a total flow rate for 4 households. Let's calculate it. Yep. Either you do this by using this method, this long method, that you need to calculate first here ch1 matlab, that is carbonate hardness of first, and you need to multiply it with the quality of water, and you then again you need to, here it is 0, so no matter to calculate quality, no matter to calculate that flow rate of second, flow rate of carbonate hardness of second thing, and here you need to calculate total flow rate, that is overall flow rate. Okay, so this basically this is a long method, and we generally in gate examination with there is a very less time there, so we generally avoid that to adopt these long methods. So we need to follow the smallest method we'll get. Okay, so first we need to find this quality, sorry, first we need to find this flow rate, and here that each household gets treated water of 540 liter per day. So there is a 4 households, so multiply it with 4. Give me a second. Multiply it with 4. Multiply it with 4, and we'll get a value of, let's calculate its value, that 540 multiplied by with 4, and we'll get value 2160 liter per day. Okay, and we have a resulted hardness of 75 milligram per liter, which is after, which we get after adding the softener. So if you do by using this formula, you'll get, let's say there's a x liter per day in 420 milligram per liter. So you'll easily get this total carbonate hardness is 75 milligram per liter, x into which is flow rate of first, into 420 milligram per liter plus 2160 minus x, that is the remaining thing, which after flow rate of first and into carbonate hardness of second, which is 0, and upon total flow rate, which is 2160. You'll easily find the value of x here. Or if you want to do this question very fast, just forget these things and do it by just using common sense, that here we given, wait a second, it takes some time. Oh my god, what's happened? Why isn't it working? Yeah,